All right, so page 21 in the packet. Okay, so starting with number 1, consider the curve x squared minus xy plus y squared equals 4. It says find 2 points on the curve at x equals 0. It's just asking for order pairs, so we can go directly into inserting into the original function and finding the y values. Hey, morning. Good. Today I'm going to back from yesterday. Okay, y squared equals 4. I can solve for y.
Top left. Yeah. Page 21.
For roots. Now, what that tells us is that we have 2 points that 2 order pairs, both order pairs share the same x value, 0.
Just one more. Just keep it.
So order pair at 0, 2, and 0, negative 2. Okay, so we have our 2 order pairs. Find dy dx. So we got to differentiate implicitly, and the way we know that is we look at the equation, we see y's mixed into the equation, and we have to go through implicit differentiation, right? As soon as you see something strange about the y, where it's placed, that exponent, usually it's just y equals, right? We usually don't have anything that's where the y is, it feels, yeah. Anytime if y feels out of place, that means you got to go through implicit, okay? So, so a couple of things to watch out for. You guys see the need for product rule here?
Yes.
Yeah, so there's product rule here, and also something that's a little bit gotta watch out for is that negative as well. Because once that product rule gets expanded, we have to distribute that negative through. So I like to protect that xy with a set of parentheses so that when I expand that using product rule, I don't forget about that negative. So there's my setup for my next step, which is product rule. So x squared becomes 2x minus all that is for that middle term xy. So f prime becomes 1. G is y. Back to f. G prime. So y's derivative is 1 times dy dx. So that completes the xy portion. We have to keep going though. Y squared becomes 2y. dy dx, right? We're asking for y's derivative. We need to include that differential variable. And then what happens to the 4?
0.
0, yeah. We don't want to make sure that we take the derivative of both sides of the equation, that we don't just let one side get all the derivative and the other side leave.
When you do the product rule, you have to take the derivative of everything else.
That's right. I got ultimately I'm taking the derivative of everything here. It's just that the middle term requires a product rule because the way that it's multiplied together. So that completes our derivative step. And now the rest of it is we're just trying to clean up and trying to get this derivative variable by itself.
Do you not have to attach the dy dx to the first one, like the 1 times 1?
Right. Why do we not attach dy dx for this y here?
Because it's not the derivative.
It's not asking for the derivative, right? G is asking for just the original G variable or G term. It's not asking for the derivative. So the only time dy dx will pop up is if it's asking for the derivative, and second, if there's actually a y that's involved in that call. Okay, distribute the negative through. Okay, so now it's just trying to add, subtract, multiply, divide, trying to get a way to get that dy dx by itself. I'm going to put the two dy dx terms together on the left side. Everything else, I'll move over to the right side. Factor out my dy dx. And then divide the parentheses over. Okay, the order that you put your terms in is not that important. I can say negative 2x plus y. I can say y minus 2x. The bottom, I can say negative x plus 2y. I can say 2y minus x. Okay, there's my derivative. Now I see a bunch of variables here. Can I just start canceling out these variables? What do you guys think?
No, you can't.
We can't. Okay, why is that?
Because the coefficient attached to it.
Something else. It's added or subtracted. Okay, we cannot cancel across addition or subtraction. Now, if the only thing showing was just 2x over x, then we can take an x out. But as soon as you bring in addition or subtraction, it's stuck. Well, unless you can take out a GCF for both the numerator and denominator, then you can maybe cancel out. But here, we have to leave that alone. This is as far as we can go. Okay, so this is my slope formula. Whatever this curve, original curve looks like, this is gonna do the job of telling us the steepness of any single point on that curve. Okay, any questions so far? Okay, you want to take that?
Are you having a help session Friday morning as well?
Yeah, Friday morning. This is what it That's good. I mean,
Kind of cool.
yeah, at first, I mean, that stuff might take a little bigger, but it's yeah, like the front load lines, some things there.
All right. Let's see. Find the slope of the line's tangent to the curve at points found in part A. So slope of the lines, we know that our ordered pairs can help us find slope using the derivative. So we're just going to Oh, and then that's going to lead us to part D, write the equation of tangent line. So we're going to gather everything that we can. So we're going to take our order pair, find the slope using the derivative, and then point slope form. So I'm going to do 1 point at a time.
What is the tangent line? I was a little confused by that.
Tangent line. So tangent line is this. So whatever the graph looks like, let's say this is the equation. Let's say this is the curve. Okay.
Yep.
Tangent line would be creating an equation of a line that's going to skim the surface of the curve at that point.
Okay.
So to get that tangent line, we just need to figure out a single point, the steepness of that point, steepness of that curve. And then from there, we can do point slope form. Okay, so part C here. Okay, so I'm going to take 1 point at a time. First point, just going to choose 0, 2. Then if I have a point, I can also use that point to find my slope. So here's my slope. Now the notation for slope, usually we do like f prime of 0 or something like that. But here, the derivative requires both the x and y. So the notation that we use is we say dy dx, and then we skip this vertical bar, and then we indicate the point. And that's just, this is an indication that, okay, I want to show that I'm about to insert my order pair into the derivative, and I'm going to get a number, and that number is going to be my slope. So 0 in for x, 2 in for y. Okay, another grade is page 21. So once I have my order pair and I have my slope, I'm ready for my point slope form, which is really part D. I'm just going to go ahead and finish it off right there. My second point that I found from part A is 0, negative 2. Do the same work. Insert the order pair into the derivative to find my slope. Vertical bar. Slope also 1/2. So those are my tangent line equations that happen to, yeah, those are my tangent line equations that will skim the surface of the graph at my 2 points that's indicated at the beginning of the problem. Okay, questions so far? Part E says set up and write equations, but don't solve, in order to find vertical and horizontal tangents to the graph curve. So let's say this is what the graph looks like. Right? Let's say the graph looks something like this, where slope 0. Something like that. Okay, and it's not a very good graph here, but vertical tangents would look like this. Vertical tangent would be where the slope is undefined, so something like this. Right? We can't have a vertical line and have an equation for that. So this is considered a vertical tangent line. A horizontal tangent would be where the slope is 0, right? Those would look like that. Okay. So the way that you can look at a derivative and ask it to find these locations where the graph is kind of flattening out, leveling off with the slope 0, is setting the numerator of the derivative equal to 0. Now, anytime I'm looking for places where the slope is undefined, like a vertical tangent, then I'm going to set the denominator of the derivative equal to 0. So my numerator is y minus 2x. So if I can somehow solve this y minus 2x equal to 0, this is going to take me to the location where I'm going to arrive at these horizontal tangents. Now, obviously, this is not the picture of the true graph, but just to kind of give you a visual as to what we're looking for if we were to solve for that. Okay. Vertical tangent. Anytime I'm looking for a vertical tangent, I'm basically looking for where my slope is undefined. And the place where my slope is undefined is basically going to be wherever causes my denominator to be 0. So if I set the denominator of dy dx equal to 0, that will tell me where the slope is undefined. So again, horizontal tangent, another way of saying it is slope 0. Vertical tangent, another way of saying it is slope undefined. So my denominator for my derivative is 2y minus x. Now there's too many variables here, so it's hard to solve, but if we were to solve, we would go about doing that. Okay, any questions here? At page 22. Okay, I'll go over this more in class, but for number 2, it says, if G is differentiable everywhere, and this is the G of X function, find A and B. So what does differentiable mean? Differentiable means it's a smooth curve. So we learned from Unit 1 limits that if I want to find where limit exists, the graph has to arrive at this. They have to point to the same y value. So it's a smooth curve. We want to figure out where A and B can be so that the two graphs are not only going to connect, but they're going to connect in a way where it's going to be a smooth curve, where it's going to be a nice smooth transition. So it's not going to be a sudden sharp turn from one graph to the next. So the thing to keep in mind is that whenever you see differentiable, that means a smooth curve. That also means it must be continuous, right? We can't have a smooth curve without the graph actually connecting at those points. So I want to say this: continuous and differentiable. So we know that the point in question is at -2, right? You have two branches, and right now we're trying to find a way to get these two branches to meet up. So the continuous portion is that we know these two equations must share the same y value, right? If they don't share the same y value, then we know that these two graphs are not going to end up at the same point. Does that make sense? Okay, so let's say I had two graphs here, right? And I have two branches that looks like this. Do these two branches share the same y value at -2? They don't, right? But what would it look like if they actually share the same y value at -2? What about now? Now it does, right? So if they share the same y value, then we know that these two graphs are going to connect, right? If these two graphs connect, that will help us do the continuous portion of the graph. So the continuous portion of the graph is we just set the two equations equal to each other because we want to force these two equations to share the same y value. So all right, so we got to work that out. We'll save that, do that in a second. Now, differentiable means it's a smooth curve, okay? Smooth curve means that these two graphs, whatever they look like, they must not only share the same point, they must also share the same what? Slope. They must share the same slope. So slope means I have to involve what? I need to find their what?
Derivative.
Derivative, right? Derivative is slope. So not only are we going to set the two equations equal to each other, we're going to set their derivatives equal to each other. So that means we need to find both of these derivatives, set them equal to each other, and then we need two equations because we have two missing constants. So we have the equations equal, right? That will do the job of connecting them. But we also need to set their derivatives equal to each other because we want these two graphs to nicely transition from one to the next. We don't want a sharp turn. If we have a sharp turn, then it's no longer a smooth curve. It's no longer differentiable. So let's find each of their derivatives. What's 6x cubed here?
8x squared. Or
6x cubed.
18.
Yeah, 18x squared. Minus
16x.
And then plus
0.
0. Okay, so that's the derivative of my first equation. Okay. Now let's find the derivative of the second equation. Now remember, you're going to treat a and b like constants. Treat a and b like you would if it was like a 5 or 6 or a 9. So what's the derivative of ax? Just a. And what's the derivative of b? 0. Okay. So we have two equations, and now we just want to figure out a and b. Okay. What's the x value that we can use? Close. -2, right? Because we know that that's the point in question. That is all we're concerned about. We want to know, are they connecting at 2? Or is there a smooth curve at 2? So we're going to replace every x with 2, and that should allow us to get closer towards solving for a and b.
Why not -2?
Sorry. I'm sorry. I meant -2. Thanks. So -2 goes in for all the x's. Okay, we clean all this up. We get -72.
Wait, why didn't you plug in -2 into the derivatives equal to each other?
I'm sorry.
Why didn't you put -2 into the equation with the derivatives?
We are. I just haven't gotten to there yet. Yeah, so I'm working on both sides of the equation.
Okay.
Yeah, but yeah, we're gonna need to do it on this side as well. You will get to use your calculators on your test. All this works out to be just some number here. Add that together, and we get a equals 104. Okay, so we have one constant figured out. Now we just have to insert into the other one and help us solve for B, right? Ends up B equals 136. So the big takeaway here is, if you're given the piecewise function and it's asking you to create a smooth curve, you're going to take the two equations, set them equal to each other, find the derivative, set their derivatives equal to each other, replace the x with the number that is in question, and then you're just down to two systems of equations and just try to solve for one equation and use the value to help you solve the other equation. Yeah, only if it says differentiable.
If it didn't say.
If it didn't say, yeah, I'm not going to give you a question that didn't say that.
Okay.
Yeah, it's going to be just like this.
Okay.
Yeah. And this is important because this shows up a lot on the AP exam. So, because so this is kind of forcing students to see, oh, do we know what this means, and how do we involve derivatives to help us move through this problem? So it looks exactly like this. You see that? Set two equations equal to each other, find the derivatives, set the derivatives equal to each other, replace all the x values with the x value that you see, and then just trying to figure out a way to algebraically solve for the constants.
For the x values, will there always be one that's like greater than or equal to?
Yes, that's right.
Okay,
Yeah,
so that's
because
the one
it has to
you pick.
connect, huh?
So that's the one you, or
I mean, it's the same
It's-
value,
yeah,
right?
it's
Yeah,
the
so
same
it's
value.
always gonna be one number. You never have to choose between two numbers. Okay, part A, this is number 3 here. If h of x equals f of x times g of x, find h prime of 2. Before we can find h prime of 2, we first have to find what? X, yeah, gotta get to my derivative first. So to get to my derivative, what rule is needed to help me get to the derivative here? Product rule, right? Because f and g are related to one another by multiplication. So go through product rule first. H prime is equal to f prime g plus fg prime. Now we can do what? Replace every x with 2, right? Yeah.
Yes.
And replace every x with 2. So now we go to the graph, and the graph is going to help us find either the y value or the slope, right? The f prime, g prime is asking for the slope at those points. So I'm going to just highlight those points here. Looks like they intersect, so f prime of 2, that's the slope of the f graph at 2. What's the slope of this line segment here?
it's -1.
-1, right? Because it's going down 1 over 1. We always read the graph from left to right. This is a negative slope. So f prime of 2 is -1. All right, g of 2. What's the
2.
2, right? Y value. F of 2.
2.
Also 2. Yeah, they intersect. And now we want the slope of the g graph at 2. What's the slope of this line segment?
1.
1, right? Up 1 over 1.
So it doesn't matter.
Well, I'm just going to pick a point that's on this side of the line. So I can just find a point that's easier rather than trying to find a point that's halfway through.
So, because I know some of them it's like undefined if it's like.
That's right. Yeah. So if it's ever asking about a slope that is at a sharp turn, then you're going to say, yeah, it doesn't exist. And that's going to cause everything to fail. You just
Okay.
say that.
So in this case, since left of it, it's like the same leading up and then it still like continues through. even though it like plateaus, it wouldn't be,
Well, I'm talking about the slope at this point, though.
okay,
I'm not talking about the slope
Yeah.
at somewhere along this, the end of this line. I'm talking about slope at that point.
okay.
That steepness is right. That's not to say, yeah, if it was here at the corner, then I'll have to say undefined,
Okay.
but that's still a slope of 1. Okay, so -2 plus 2 is 0. So it ends up h prime of 2, which is 0. Okay, part B, I think this is what gives students a little bit more trouble here. W of x equals f of g of x. Okay, we want to find the derivative function first. But what's involved here? Is this also product rule?
And chain.
This is all just chain rule.
Okay.
Okay, so do you see the difference between chain rule and product rule? Basically, you count the x's. Okay, if you have 2 x's, that means you have 2 functions. Here, there's only 1 x. It's a function within a function. So this is chain rule, right? And I think sometimes students mistake chain rule for product rule, so just be careful, right? Recognize that as chain rule here. Okay. So we got to do chain rule. Chain rule says outsize derivative times insize derivative. But we were on page 22 in the test review packet. Okay, so outsize derivative, how do I represent outsize derivative? Or what's the outside function? It's the f, right? So I have to say f prime of g of x, yeah. So now that I've taken care of my outside portion, now I'm moving on to my inside portion. So what's inside function's derivative? G prime, yeah. So not only do we have to know how to apply chain rule, we have to be able to spell it out using function notation. Does that make sense? All right, so now what's the next step? What can we do next?
Plug in 3 for
Plug in,
X.
good. Plug in 3 for all the x's. Take it one step at a time. Don't try to do too much. Yeah, I see some students, they get to this point and they're good, but then they try to get the answer from here to the, just from here. But we still have a few more steps remaining. We can't quite get to the answer yet, but we can find some information that can help us give us a stepping stone here. So what's achievable? What's easy to find based off what we have so far? Okay, we can find g prime of 3. That's just looking at the graph. And what else is easy to find? G. Right. So we're going to find those two first. It doesn't quite get us to the answer, but it will get us one step closer. Okay. So let's go to 3 here. Okay. G of 3 is up here. All right. So what's G of 3? 2.5. Okay. Put that to the side here. And what's G prime of 3? 0. It's a flat line, right? So that's a slope of 0. There's no steepness, right? Slope of 0. So G prime of 3 is 0. Now make your substitutions. We haven't gone to the answer yet, but we are making substitutions here. So W prime of 3 equals F prime of, now I can replace G of 3 with what? 2.5. Okay, so now this becomes F prime of 2.5 times G prime of 3 is 0. Now we know everything times 0 is going to be 0, but let's just go ahead and just go through the full step here. F prime of 2.5. So let's find 2.5 on the F graph. What's the slope of this line segment? -1, right? So it doesn't matter if it's a decimal, right? It's still along the same line. So this is still -1. Therefore, -1 times 0 is 0. Okay, part C, if z of x is equal to 2 times f of x cubed, find z prime of 0. We need to recognize this as chain rule because I have a function inside a set of parentheses. I have a bracket parentheses with things outside of it. So this is telling us we got to use chain rule here. Right, anytime you have parentheses with things inside and exponent outside, we got to do chain rule. So chain rule, there's outside and inside portions. What's the outside portion of this expression? 2 parentheses or 2 bracket cubed. And what's the inside?
F
F
of
of
X.
X. Okay, so let's build it out. We're going to find the derivative, outside derivative times inside derivative. All right, so what's outside derivative? 2 parentheses cubed becomes what?
6 parentheses squared.
6 parentheses squared. And what do we put inside?
F.
Good, the original function unchanged. Right, so we're basically applying what we're doing here, right? Outside derivative with inside intact times, now we're ready for inside derivative. What's inside derivative?
Prime X.
F prime of x. Now that we have our derivative, we can do what?
Plug in 0.
Yep, replace 0 for all the x's. Okay, so let's go to 0 here. F of 0 is 4. Okay, so 6 times 4 squared. And then f prime of 0, so the slope of the f graph at 0,
-1.
-1, right? It's nice. There's the same slope all the way through along this line segment. (16 times 6 times -1 is -96. Again, you'll get to use your calculator on your test. Okay. Part D, let's do one last one here. Part D, if k of x equals f of x, find k prime of 4. What does this look like to you? What rule do we have to use here? Chain rule. So outside derivative times inside derivative. My outside function is f. Leave the inside alone. Times the inside function derivative, so times f prime of x. Next step, replace every x. No, so we have our derivative, right? Replace every x with what? 4. Then piece by piece, gather information until you can get it down to a number. All right. So what's achievable is finding f of 4 and f prime of 4. We don't want to do too much. So what's f of 4?
2.5.
F of, well, that's g of 4, right?
Oh,
F of
bad.
4,
2.
just 2. Put that to the side. What's f prime of 4? 1. Yep, it's a slope of 1. Okay, we are not at the answer yet, but we're getting closer. Replace what I underlined in red with the value that we found. So now we're almost there, right? Now there's one last piece to find, and that's to find what? F prime of 2. So we want to find the slope of the F graph at 2. What's the slope of the F graph at 2? Negative 1. Yep. Okay, I'll finish off the rest of this packet worksheet for tomorrow, 5th period. And if you can make it great. If not, I will have a team session and I'll also record it. Okay.
Do the help session tomorrow morning.
Yeah, just have, yeah, it's on the board there. I can't, yeah, I'm not talking tomorrow morning.
Thank you.
Thanks.